What is up, YouTube? Woo! This is Mr. King coming at you live, back and better than ever. We have a new subject today. It is physics. So thank you for joining me on this journey where we learn about motion for today. So if you're taking notes, what I like to do with students is have them split their notebook into halves. On the left side should be words. I prefer in your own words, but try and think of words that make sense to you. They may not make sense already, so you can use your own words, and that's the best way you'll learn. On the right side, please put pictures. You can use the pictures on the screen, or it'd be even better if you can come up with your own pictures that connect to the words on the screen. Yep, and the right side would also be graphs. So today we're going to learn about velocity. So on the left side, could you write that velocity means speed and direction? So speed is how fast you're going, but velocity is a little bit extra. The extra part is that velocity in this case would be speed and it's going forward. And velocity, the convention in physics is that velocity is positive if you're going forward or if you're going up. Those are the two ways velocity can be positive. And since velocity is direction, velocity can also be negative. So speed, the difference is speed is always positive because you're always going to be moving. But velocity can be negative because it does do with direction as well. And that's why physicists use it, is because it's a little bit more descriptive than speed. So velocity is negative when you're backing up or when you're going downwards, like if you're skydiving. So I have a practice problem for you. Homer Simpson backs into the bushes 2 meters away in 1 second. How fast is he going? And what is his velocity? Please pause the video now and answer the question. Hopefully you remember that the speed formula is 2 meters per second, or distance divided by time. So you take the distance he went, 2 meters, divided by 1 second. For velocity, he's going backwards, so it should be negative. So you take the 2 meters, the 1 second, but now it's negative. So velocity is a number, but it's just negative because of the direction. Okay, another practice problem for you. Space is 10,000 meters off the ground. The latest rocket can make it to space in 1,000 seconds. How fast is the rocket, and what is the velocity? Try and do the math here. I'll give you a sec. On the right side of your notes, you can draw a spaceship. On the left side, you could show your work for how you got the speed and the velocity. And since it is going up, the answer for velocity should be positive as well. Okay. And now we're going to talk about position versus time graphs. So for this graph, it's tempting to think of this car moving diagonally, but actually, so the left side on the y-axis we have position, on the x-axis we have time. So this graph means that the car is moving up while time is going on. So this car is just moving forward. And the reason why the line is straight is because the car is moving at the same speed. So the slope is the same throughout the time. So this graph for position versus time means that the car is going forward. Whereas this line where it's flat, this means that the car is staying in the same position, but time is still going forward. So this means that the car is not moving for a position versus time graph. And if you're going down, so it starts up, but it goes back down to 0, that means the car is going backwards. So I have a practice question for you. Try and draw what this car is doing. So try and draw what that truck was doing. I'll give you a sec. Try and draw on the right side of your notes. Have a little position versus time. You don't need a grid. You can just have the L for Y and X axis. Hint, the truck is going forward, and then it slows down, and then it stops. So what do you think that would look like? Hopefully you noticed if it's going forward, goes like this. This is a little advanced, but you need to give it time to brake. It can't just drop on a dime and stop. So the slope decreases gradually and then it goes flat. So this is the car going forward. This is the truck braking, and then this is the truck stopping. That was a tricky one. The brake threw off a lot of students in my class. Next, how about this scenario? Mr. Keene wanted to run around the track, started at 0, but got tired halfway. So I took a break, and then I ran back to the start. How would this position versus time graph look? Take a sec, do it on your right side. Hopefully you notice that it's a trapezoid. So it starts out running forward, assume at the same speed. You could have a little curve, but I assumed everyone would put it at the same speed. Then I took a break, and it was a long enough break so I could run back at the same speed too. Okay, so let's say you have this position versus time graph. Try and guess, what do you think a velocity graph would look like? So if velocity was in the y-axis, and time was in the x, what is the velocity the whole time? So if you have a position versus time graph like this, that means the velocity graph is going to be a flat line. That means it is going the same speed. That's why it's flat. So if the velocity is negative, that means the car is going backwards, but it's still flat because the car is moving at the same speed. And if the car is not moving, the position is flat, so is velocity. Okay? A new word for you is acceleration. Acceleration means change in velocity. So most people know what acceleration means already. They think it means going faster. But technically in physics, acceleration means anytime you change the velocity. So that can be slowing down or speeding up or changing direction. So drifting, like in Tokyo Drift, that is accelerating. Them going around the bend and drifting, that's accelerating, speeding up, and slowing down. Those are all acceleration. So please write acceleration is positive when something speeds up and negative when it slows down, if they're both going forward. So two things are going forward. Acceleration is positive if you're speeding up, negative if you're slowing down. And two more questions for you. If the position versus time graph looks like this, what do you think the car is doing? So on the right side of your notes, please draw this graph. On the left side, please guess, what do you think the car is doing if the graph looks like this? Hopefully you notice that the speed is increasing every second. So if the speed is increasing, because the slope is increasing, the speed is increasing. So if the speed is increasing every second, the car is accelerating. That's why the position versus time graph is a curve, because the slope is getting steeper, so it's getting faster. So the velocity graph will look like this. It's accelerating at the same speed, so it's going faster and faster. And if a car is slowing down and braking, the velocity graph will go high and then go to 0 if it's braking, and if it's going backwards, it'll be in the negative. That's the last thing for today. Thank you everyone for staying with me the whole time. Have a great day. Bye.